Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Dame Quince or Dame Quince. Uh I think it's actually supposed to be Dame Quince because I think that's translated in Spanish is give me 15. And there's a lot of 15s in this puzzle. Anyways, it's by Sudoku, who is a really cool setter. I think it's a she, but I'm not sure. But she sets a lot of really cool puzzles. And hopefully this should be one of them because this has a high rating. Anyways, let's get to the rules. We have normal Sudoku rules apply. That is, each row, column, and 3 by 3 region has to contain the digits from 1 to 9 once each. We also have killer cages, where digits in a cage do not repeat and must sum to 15. So, for example, if this were a 7, this would have to be an 8 because these two digits must add up to 15. Oh, and she says specifically, all the digits in the cage must sum to 15. So, because they're all 15. Anyways, those are the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Actually, before I'm going to get started, I'm going to pause because I want to go to the bathroom first. I'm going to pause first. I'll be right back, and then we'll start the puzzle. Okay, I'm back. Let's go. Okay, we have a lot of 15 cages, and we have particularly the ones that are most interesting right now are the 5 cages. And yeah, pretty much the 5 cages. Because if you have 5 digits adding up to 15, it has to be the lowest 5 digits. Because the minimum is 1 plus 2 plus 3 plus 4 plus 5, which is exactly 15. So these are the digits 1 through 5. We know these 2 digits must match these 2 digits. 2 digits. So this one specifically, these 2 match these 2. And therefore, all these digits are 6, 7, 8, 9. This is 6, 7, 8, 9. Because we have a 1, 2, 3, 4, 5 quintuplet in row 9. Therefore, these 2 digits add up to 15. That's interesting. And this is 6 through 9 also. That's interesting. This blue, where is this cell? This cell cannot be any of these. Can't be this one. This cell must match this one. So this is orange, and therefore one of these is orange. This blue then must be this blue, which forces the blue to be one of those two. Let's see. This digit must add up with this digit to add up to 15. But if it were one of these two, that doesn't work because these two specifically add up to 15. So they can't add up to 15 with either of these cells, right? Because this cell must match with this one. These are different ones. So we're going to make this yellow and these red. This then must... this is red. This then must be the yellow cells matching together, right? Because the red ones match to 15. These add up to 15, but again, this cannot have this set. What else do we have here? These are also 6 through 9 here. This is 6 through 9. This blue cannot be here. Okay, yeah. There we go. So this blue cannot be this in this cage because we can't have repeats in cages. So this blue has to be here, which makes this 1 through 5. The last digit then is a 6 through 9 and is the yellow 6 through 9 here. So the blue must be here, here, and here. This yellow and red must add up to less than 15. Because these two add up to 15, and if this is more than 15, obviously it doesn't add up to 15 for the 15 cage. So 9 can never be here. So 9 cannot be here, which means these cannot be 6. Actually can't even be. It could be 6, 8. One of these is a 6 here. We're not sure which. This can't be 9 here, because this matches this cell. It has to also be one of these. What digits can this blue be? It could be 6, 7, and this is 2, or it could be 6, 8, and this is 1. Those are the only possibilities. So this blue is 1 or 2 here. This is 1 or 2. This is 1 or 2. This is 1 or 2. What else do we have? One of the this yellow has to be one of these yellows here. And this yellow has to be one of these 3. The blue one has to be one of these 3 cells here. And this orange one has to be one of these 4. Okay, so the blue cannot be any of these. It can't be either of these because it sees all of these cells. So this blue cannot be in this 15 cage. That's interesting. Also, we know 6 has to be one of these cells, right? It has to be 6 and 7 with 2, or 6 and 8 with 1. Of these 2 digits, only one of them can be 1 through 5. So the other digit has to be 6 through 9, at least. Can you have more than 1 6 through can you have more than one digit that's from 6 through 7? I don't think so, right? If you have 6 and 7 here, that gives you 13. And with 2 unique digits, that can never add up to 15. So one of these has to be the orange. The rest of these digits are 6 through 9, actually. Oh, that's interesting. So one of these is 6 through 9. The other one is 1 through 5. So we know the orange is here. These also cannot be 6 through 9. So these are also 1 through 5 here. Interesting. And it cannot contain 1 out of 1 or 2. Right? Because the blue cannot be... The blue will see this cell from this box. It will see these cells from this cell here. So this can never contain a blue, which is 1 or 2. So it cannot... Then it does... can it ever be 2? You could have 2, 3, 4, 6. Or 1, 3, 4, 7 at most. So this is 6 and 7 here. With 1 through 5. These all add up to 6, 7, 8, and 9. So the remaining digits, we have a 6, 7, 8, 9 quintuplet or quadruplet in column 9, which eliminates 6, 7, 8, 9 in the rest of the column. Therefore, these are 1 through 5. This is 1 through 5. These two add up to 15. Therefore, this one plus this one must add up to 15. So this is 6 or 7. This has to be 8 or 9 then. Okay. And these specifically must match this pair. Hmm. Interesting. Right, because you can, in the 15 cage, do you have to have something that, for cell 15 cage, I think you always have to have one digit that is from 6 through 9. Right? If you don't, the maximum you can have is 2, 3, 4, and 5. Interesting. Right, you could have up to 1, 2, 3, and 9. That works. But in every 4 cage, you have one digit that has to be from one digit has to be from 6 through 9. Which means, right, because you can't have two digits from 6 through 9. We tried that. So if we had 6, 7, 8, we tried 6 and 7. Then the minimum is 1 and 2 with that, which adds up to 16. So because of that, this is at most one digit from 6 through 9. And it has, this is at most one digit from 6 through 9. And we already have 3 digits from 1 through 5. So this cannot be the orange. It's specifically 6 and 7, which means this cannot be the 6 or 7. It's the 1 through 5. That's the orange. These two digits cannot be, well, we don't know. The orange one has to be one of these 3 cells. And there must be a 6, 7, 8, or 9 here. So we have 2 digits here from 1 through 5. This must also be 1 through 5. This is an orange. And we have another digit from 6 through 7, 8, and 9 here. But we have 2 digits from 1 through 5 here. This is 3, this is 4, this is 5, which forms a quintuplet. Therefore, this must be 6 through 9 here, which makes this 1 through 5 here. Now this could be part of this cell. This is also 6 through 9. That's interesting. One of these is 6 and 7. Cannot be the pink 6 or 7. Well, it's 6, 7, 8, and 9 here. Okay. Because of that, these two are from 6 through 9. Can both of the yellows be here? No. So that means this must be one of the yellows. And the other one is one of these two. We're not sure. But the yellow in these 2 cells, one of them's here, and one of them's one of these 2 cells, and this one for certain has to be a 6 through 9. So one of these are 6 through 9. This then cannot be 6 through 9 because we have one of these being 6 through 9. We have 2 here. This is another one here. So yellow, one of the yellows does have to be here, which means this cannot be yellow. Which means this is a corresponding yellow. We don't know if that matches the pink, though. It could. This is 1 through 5. This is 1 through 5 here. Um, so this has to be red. We know for certain this is red. So one of the yellows is here. That matches this one. So it must match one of these three. We don't know where this other 6, 7, 8, 9 is. That means these both have to be the red 6, 7, 8, 9s, which forces this to be 1 through 5. Right? Because this red 6, 7, 8, 9 cannot be here. Cannot be here because that's taken by the yellow 6, 7, 8, 9. So this has to be the red 6, 7, 8, 9. Both red 6, 7, 8, 9s cannot be in here. I guess they could be here. It's possible. But, is that actually possible? So if these were both red, the only way that that would be is if the yellow would be here, but then the yellow 6 would have to essentially be here. Right? It would have to be 4, 5, and 6, which would force this to be 7, 8, 7, 8, but then the red would be 6, 9, 6, 9. So one of the reds cannot, both of the reds cannot be here, because that would imply the red is 6, 9, but to have neither red be in here would imply that the yellows are 7, 8s. But then the red would have to be 4, 5, and this 15 cage would have to be 4, 5, and 6 without the reds. So the red, one of the reds has to be here, the other red has to be here. And we're not sure which one's which. These can't be 6 anyways. So this can't be red. Both reds cannot be here, obviously, because they add up to 15 already. So one of the reds is here, one of the reds is here. That's possible. Okay. We have 5 digits in 5 cells in column 6, which must contain the digits 1 through 5. So the rest of the digits are 6 through 9 here. So this is 6 through 9, this is 6 through 9. This must be a yellow. This is a yellow, so these are both red. That's interesting. One red must be here, one red must be here. Okay. Again, we have 3 1 through 5s in this 15 cage, but we're not sure where. We're going to mark this dark, I guess, here. But unfortunately, that doesn't tell us much. Okay. This, we don't even know. It could be pink, yellow, it could be red. No, cannot be red. If this were red, the problem is then we'd have both. Well, no, it could be red here. This could be red and this could be red. That actually is valid. Okay, so never mind. That's fine. The other yellow is one of these. The 15 can, well, you could have a 9 as long as you have 1, 2, or 3 with it. Hmm. Hmm. Okay. Hmm. Hmm. What else do we know? Um. Okay, one of these is red. We know that for certain because it cannot be both reds be here because that would already add up to 15 with 2 unique digits. So one of these is red, therefore red cannot be here, red cannot be here. Okay, that doesn't tell us much. Red could be any of these. Yellow could be here. Hmm. 2, 3, 4, 6 adds up to 15. 1, 3, 4, 7 adds up to 15. 1, 3, 5, 6 adds up to 14. Hmm. That doesn't help very much. Hmm. We have 3 digits from 1 through 5 here. Can you have another yellow here is kind of the question, right? Um, okay. If this is pink, that means it must match this one, and then for it must match here, right? Hmm. So if it's red, if this 15 cage requires the red 6, 7, it could be 6, 7, 8, 9 actually. So it would have to be here. If it requires the yellow, it could be any of these 3 technically. Hmm. If this is blue, that would mean this is blue here. So one of these 3 has to be blue. if these are blue, obviously, if this is blue, then it must be here. If this is blue, then it must be here. So one of these three is a blue here. Orange cannot be any of these. Orange is one of these three. Orange is one of these four. But that's 3 rows, so that's too many. Hmm. Oh, interesting. Yeah, we have 3 unique digits, each adding, what is it? We have 3 unique digits, each of which requires a different 6 through 9 to add up to 15. So we're guaranteed at least a 6, a 7, or an 8, or 6, 7, and 9 is kind of the question, right? For these 4 cell 15 cages. But they're in different columns. So that's not that helpful. Um, hmm. Yeah, that's not too helpful, unfortunately. What else do we have? Bingo. Okay. Right. If we have a red, well, that's not true. Okay, never mind. I was thinking that to not have, yeah, that's not correct actually. Huh. Actually, can you have two reds here then? Actually, well, you can't have two reds because one of these is red and one of those is red. But you can't have two reds here either. So one of the reds must be here, one of the reds must be here. You could have two yellows here. That's one thing I think I made a mistake in. Because you don't have to have 4, 5, 6 here to be essentially to have a yellow and a red here. It could be like 1, 4, 1, 5, 9, right? And that would satisfy things. Um, um, hmm. Though if you did have two digits which were not which were part of it. Oh, that's interesting. That would mean this is 6, this is 7, 8. So the other 7, 8 would be here. Um, then both of these would be yellow. This would be 7, 8. That may, interesting. Red, the other red 6, 7, 8, 9 has to be one of these three. But again, the red could still be part of the pink. Um, Hmm. One thing you cannot have. Okay, that's interesting. One thing you cannot have in this set, or what you have to have, I guess, is you cannot have 3, 4, and 5 here because that adds up to 12, with 6 adds up to 18 already. So you have to have 1 or 2 with the other 3 or 4, right? Hmm. Hmm. Um, could you have 7, 8, 9? It's just hmm. Hmm. Well, you could have, huh? Again, you could have these 3 adding up to, with a red and a yellow in them. Two, it's like a 6, 7 or 6, 8 again. Hmm. I mean, that's possible. We know this here matches this. We have all the blues matching. We don't know about these. Hmm. This could be red, could be yellow. We don't know which. Hmm. We know one of these is red, so this can never have a red. 6 through 9 here. That's fine. We don't know which one this matches to, unfortunately. This one has to be one of those 3. Hmm. Must sum to 15. Okay. Hmm. Um. Okay, so if the yellow are the same as the pink, obviously this would be 6 or 7. This would be 8 or 9. This would match then this, which would match that. This would match this. So this would match here and here. And it would have to be one of these. It would have to be here and then one of these two. This would be red then. Actually, that's interesting. Yeah, so if the pink matches the yellow, so say these were yellow. That's interesting. Then this would be red. These couldn't be red. One of these would be red. This would have to be a red here. This would match here, which would match that one, which would then match that one. That would have to match that because these are the same. Therefore, it'd be one of these two. Hmm. So this would be 8 or 9, if that's the case. This would then be red. Okay, so say it wasn't matching. Say the pinks were red then. Okay. That means the other, this would be yellow. One of these would be red. The other one would be yellow, but we're not sure which one's which. Hmm. This can't be red, but this still could be red here. None of these could be red. So the other red would have to be one of those two. Hmm. Yeah, I'm not sure. Okay. Okay. Mm. Oh, wait, that's interesting. Hmm. You have one of each of these. You have at least one of each of these, right? This is one, two, three, four, and five, contributing to these 15 cages with 4 cells. This would have to be the same as either here, here, or here. This orange is the same as this. So we know these two are the same. Therefore, these two contribute to the 15. Plus these 3, so that's 15 already there. The orange contributes twice because one of these is orange. One of these must be blue. We also know this is blue, actually. So or this or these two are blue. We're not sure which. This cannot be orange because it sees all three of these and this one. So orange has to be one of these four here. That's interesting. Hmm. So this adds up to 15 here. 1, 2, 3, 4, 5. We also have 3 digits. Or sorry, 2 digits that are 1 through 5, and another digit that's 1 through 5. So those are 3 distinct digits. So we have all 5 digits here, and then we have another 3 distinct digits, and then we have a separate digit. And those with so that's 4 other digits then. 15, 26. What is that at a minimum? You have 1, 2, 3, 4, 5 guaranteed. So that's 15 plus 1, 2, 3 plus 1. It cannot be 1, 2, and 3 because this is a 1 or 2 here. So this is at least 1, 3, and 4. So you have 1 through 5, that's 15, plus 1, 3, and 4 at minimum, that's 8. So that's 23 plus 1 at minimum. Right? You have 1, 2, 3, 4, 5, 1, 3, and 4 at minimum, 8. So 15 plus 8 is 23, plus 1 is 24. And the minimum amount, so the minimum amount for these non 6 through 9 digits in these 15 cages is 24. That's the minimum. So the maximum the non 1 through 5 can be is 6, 7, and 8. Right? Because so that's 21. So we know we need exactly 1, 3, 4 here. And this is 1. The minimum amounts essentially are essentially the minimum amounts also means that the maximum amount that the non 6, 7, the non 1 through 5s can add up to, the maximum is 21, which is exactly the minimum, right? 6, 7, and 8 is the minimum amount you can add to of the non 45 cells. Sorry, the non 1 through 5 cells. So we know the minimum amount here for the 6, 7, and 8 has to be the exact one. So it's 6, 7, and 8 here. And also the minimum amount for the 1 through 5s also has to be the exact amount. So this must be 1. These have to be 1 through 5. But we don't, one of these is 1. And this must be a 1, 3, 4 triplet here. So this is not 9, which means this is not 9. This has to be a 9. And this has to be 6 or 7 here with 1, 3, or 4. This 1, 3, 4 triplet eliminates 1, 3, and 4 in the rest of the column. Therefore, this is 2. This is 2. This is 2. So this can't be 2, obviously. These can't be 2, and this can't be 2. 2 can't be any of these. 2 can't be here. 2 could be here, though. This is 1, so this can't be 1. This can't be 1. This is a 1, 3, 4 triplet, which eliminates 1, 3, and 4 in the rest of the column. Therefore, this is 5, and this cannot be 5. This cannot be 5. This can't be 2. This can't be 2 here. 2 could be either here or here. 1 could be here. Okay, this is then a 6, 7 pair to add up to 2. So this must be 8 or 9. This must be 8 or 9. This must be 6 or 7. This then cannot be 2. I guess it could be 6 and 8 still here. Actually, that's still possible. This can't be 9, so this can't be 6 because the corresponding digits can't add up together. 9 cannot be here, so 9's one of these 3. This can't be 9, so this can't be 6. This can't be 1. So 2 and 5 are only in one of these sets of 15. If this is 5, you could have 1, 3, 6 here. That's possible. So with 8, you would have 1, 2, and 4. This could also be 8 also, right? So this can... either this is 8 and this is 1, 2, 4. Or this is 8 and this would be 2. And this would be 1, 4. Either way, this can't be 4. Hmm. Hmm. What else do we know? 9 could be either of these 3. We're not sure which. Hmm. 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 So if this is 8, this would be 1, 2, 4. If this is 7, it could be 1, 2, 5, or 1, 3, 4. Okay, hold up. What are the possibilities? Let's go through all the possibilities here. Okay. This is 8, which would force this to be 1, 2, and 4 here. So this would be 6 or 7. This would be 6 or 7. This could not contain a 2 at all. You could have 1, 3, 5 or 1, 4, 6. Oh. Okay, this can't be 5 here. The 5 is separate. The 5 would be with 1, 3, and 6. Right? Hmm. 1, yeah. 5 would have to be with 1, 3, and 6 to add up to 10. Because you cannot have a 2 anymore. The 2 has to be with a 4 and 8. You have 1, 3, 5, 6, and then 1, 3, 4, 7. So that seems okay. Hmm. Okay. What does that mean? I'm not sure. Hmm. This could actually technically contain 1, 2, 3, and 9 still, right? You could have 1 being here, 2 being here, and then you have 3 and 9 somewhere in these. Yeah. Not helpful right now. Okay, what are the remaining digits in column 1? Let's do that. So it's 1, 3, 4, 5, 8, 9, right? This can't be 9, though. I think, let's see, what are the possible combinations? 1, 5, 1, 5, 9. This could be yellow also. So I don't, yeah. One of those two is yellow. We don't know which. uh, if this is 1, 5, and 9, this has to be 9, and that's 1, 5. So that's possible. 1, 5, 1, 5, 9. If it's 1, 6, 8, this would be 6. This would be 1 and 8. That's possible too. You can't have a 2 in it. So 3, 4, 8 all works there, right? 3, 5, 7 also works as long as this is the 7. And then 4, 5, 6 would require that to be 6. Hmm. Hmm. Still a wide variety of things. Can the 9 ever be in this 15 cage? Ah, yes, it could. 249. Hmm. And actually, you could have a 1 here, and this being a 9. That works too. Dang it. So either this 9 is a pink, which means this is 6-9, or this is a 249 in this cage, or this could be 9, 5, and 1. Ugh. What are the possibilities here then? So obviously, if the 9 matches the pink, then this is 6, this is 9. This has to be 7 or 8. This is 7 or 8, which means the 2 has to be one of these, which is fine. You still could have 2, 6, 7 here. That's still possible. Which would make that 8 and that 9, right? Um, okay, let's go through those scenarios. Okay. If this was 2, you had 6, 7 here. So we're trying to specifically have 2 of the same here. That would make this 9 and this 8. This would be 6. This would then be 9 and 6. And this would be 7. So this would have to be 1, 2, 4. So this would be 2. This would be 4. 2 cannot be here. So 2 cannot be here or here. So this would then be forced to be 2. Which means that can't be 2. So this would be 2. This would be 6, which requires a 1, 3, and 5 to be with it. So this is 5. This is 1, 3, 1, 3. This is 7. And this would then be 1, 3, and the other 1, 3, right? So these two would match, if that's the case. Oh, well, not necessarily. I was going to say, doesn't this always match this one? It's like, no. This can't be 6 here. 1, 3, 4, 7. This can't be 7. We have 1, 3, 4. So this is a 7. Which means this is 8. 7 has to be here. This can't be 8 here. This can't be 8. This is 7. So this is 8. Yellow. Red has to be the opposite. So this is 6. This is 9. This is 6, 9. So this can't be 9. 9 has to be here. So this can't, this then has to be 1, 5 specifically. This would be 8. This cannot be 1, 5, or 2. This would be 3 and 4. This would be 6. This could not be 1, 2, or 5. This would not be 1 or 3, so this is 2, 4, 5. So far this is looking fine. So this is 7, this is 8, this is 7, this is 6, this is 9. That's looking fine. This 3, 4, 3, 4 pair eliminates 3 and 4 here. So this would be 5, this would be 1. Ah! Ah, 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 ah. Okay. Yeah. That's interesting. Okay. So that's problematic there. So the reason why that was problematic, why was that problematic? It's because this 267 forced this to be 8, which forced that to be 2. So therefore the 2 had to be here. This would force to be 9 because the 8 matches the yellows and the red has to be 6 and 9. So this would have to be 9, which would force us to be 1, 5 as a 1, 5 pair. So that would not normally be problematic here. The reason why that didn't work is it's pretty convoluted. This 2 basically forces this to be a 6. Okay, so we were specifically trying this as both 6 and 7 are here, which is the only way you have two unique, 2 digits from 6 through 9. Not one of them not be in this 15 cage. But we tried that. That's 2, 6, 7. That forces this to be 8, which forces this to be 9. This 8 must be with 1, 2, and 4 to add up to 15. So this is 2, 4. This can't be 2, though, because of that 2. So this is 2, which means a 2 cannot be here. And the only place for 2 in row 1, then, is here. Because of that, we also know the yellows match 7 and 8. So the reds must be 6 and 9. Therefore, this is 6 and 9, which forces that to be 9, which makes this a 1, 5 pair. The 2 means this can't be 2. It can't be 1, 5 because of the 1, 5 pair in the box, so it's 3 and 4, which eliminates 3 and 4 here, which makes this a 1, 5 pair, which eliminates that possibility of all different things in that cell. So, we know one of these is 6 through 9. We know one of these is 6 through 9. So this cannot be 6, 7, or 8 here. This has to be a low digit. It could be the orange one. It could be something else, right? We're not completely certain. Okay. Interesting. This orange cell is one of these 4. So unfortunately, I don't think we can extrapolate from this. Like even if we have a 2 here, that's not guaranteed that these 3 digits require 2 digits that are from 4 and 5, right? Because you could have 6, 1, 8 here, and then this would okay. Actually, I think every scenario here. So if you have only 1 digit that's from 6 through 9 here, you have 2 digits here, but those eliminate 2 digits here. If this were 2, that would eliminate the other possibility, and these 2 you would be unique. So whatever 2 digits here would eliminate those 2 digits here, and therefore the 2 would be here. Right. So I do think maybe we can extrapolate. So say this was a 2, right? If this is 2 unique if these are 2 digits from 1 through 5 here, it can't be 2. 2 would have to be here. If these are 2 unique digits from 1 through 5 here, those digits cannot be here. Therefore, they would both have to be here, but since there are 2 unique digits here, one of them has to be here, and they would see all of those cells. So that's not allowed. If there's only one unique digit here, the problem is this is 6. This would have to be 6 and 8 with a 1 to add up to 15. And therefore 1 could not be here, and it could not be here because this would be 1 and 8, and that we know there's a 1 in one of these cells. So because of that logic, 2 cannot be here. 2 actually has to be one of these two digits, which means this can't be 2, this can't be 2. This then has to be a 2. So we know then this is 2 and 4 adding up to 8, because that's the only way you get 8 here. So this is 8. This cannot be 8. This can't be 8. This can't be 7. This is either 1, 3, 4, 7 or 1, 3, 5, 6. We're not sure. This can't be 4. This can't be 4. This can't be 4. One of these is 1 or 3. This can't be 4 or 5. This is 1 or 3. Cannot be 5. Cannot be 4 because of the 2, 4 pair here. This cannot be 7 and 8. This is 6 and 9. Now we know this is 6 and 9. Okay, so this is 8. This is 7 or 8. This is 7 or 8. This then has to be 6, and this is 9. This is 7. This is 8. This is 7. This is forced to be 8. 8 can no longer be here. 9 cannot be any of these cells here or here. So this must be 9 again. And this has to be 1 and 5. But because we're not limited to 2 being here, these cannot be 1 and 5, but it's a 2, 3, 4 triplet. One of these has to be that digit here. So this is 1 or 5 here. We have a 1, 5, 1, 5 pair in column 2, which eliminates 1 and 5 in the rest of the column. This just becomes a 3, 4, 3, 4 pair. Therefore, this orange must be 1. And this must be a 5 here. So this is 1, this is 1. These can't be 1 anymore. This can't be 1. We know orange is one of these. This can't be orange then. Orange can't be here either because this is an orange. So orange has to be one of these two. And it has to be one of these two, which means orange cannot be here. Orange cannot be here. Orange does have to be here. So this is 1. This is not orange because one of the oranges is here. One of the oranges is here. This cannot be orange. And in fact, can it be 1, 3? Okay, this can't be 9. This can't be 9 or 8. So therefore, this is a low. Therefore, we have a 1, 3, 4, 5 quintuplet. One of these is 1, though, so this can't be 1. This can't be 1. 2 is one of these two. We have a 3, 4 pair in column 2, which eliminates 3 and 4 in the rest of the column. Therefore, this is 2. This cannot be 2. It is not blue. This can't be blue. This can't be yellow, so this has to be 7 in the yellow. This must be 2. This has to be a 6, 9 pair here. This can't be 2, so this must be 4, which makes that a 2. None of these can be 2. This can't be 2 either. Oops. Put 4. This can't be 2 or 4. This can't be 4. Where's the 1? It has to be here. So this is 1. This can't be 2. We don't know which ones the pinks are still. Where's the 2 in row 3? Can't be here, can't be here. It has to be here. So this is 2. These can't be 1 here. 2 has to be one of these two. This can't be 1. This is a 3, 4 pair. This has to be 8 because that's the only digit remaining in column 1. This is 6. So 1 has to be one of the digits in... It has to be here. So this is 1. 2 actually also has to be in this 15 cage. So this is 1 and 2. It could be 3 and 9. So this would be 3 and 9 if that's the case. It could be 4 and 8. This would have to be 4, and this would be not 8 here, 8 here. Or it could be 5 and 7. And you could have 5 here and 7 in one of these two spots. This can't be 5. This can't be 5. So we know the 2 is here. We know the 2 is here. Okay, this is 2 with 3, 4, or 5 to add up to 15. It can't be 3. It can't be 5, because if it's 2, 5, that would have to include 8, but we know the 8 has to be here. So this has to be 4 and 9, which makes this 7 and 8. This matches then. The pinks are essentially the same as the yellows. So since the pinks are the same as the yellows, this must be 8. This has to be the last yellow and is 7. This must be 7. This must be 8. This can no longer be 8, so it cannot be 4 and 8. It can't be 7 here. So this is 5 or 9, which means this can't be 5. This is either 1, 2, 3, 9 or 1, 2, 3, 1, 2, 5, 7, adding up to 15. One of these 3 is a 5 because of the 1, 5 pair. So this cannot be 5. This must be 3, which makes that a 5. This can't be 7, and it can't be 4. It's 1, 3, and 6, which makes this a 5, which makes this a 3, which makes that a 4. These can't be 4. 5 cannot be here. Where's the 5 in row 6? It must be here. So this is 5. This 4 means this can't be 4, so this is 3, which makes that a 4. This 3 means this can't be 3, so this is 2. Therefore, this can't be 2. Well, we know where the 2 has to be then. 2 can't be here, 2 can't be here, 2 can't be here. It has to be here now. This is 3 then. We have 6 and 7 remaining. This can't be 6 because of that 6, so this is 7, which makes that a 6. This 7 means this can't be 7, so this is 3, which makes that a 4, which makes that a 3. We already knew that because this can't be a 3. This then has to be 9. This 3 eliminates this 3, so that's a 4, which makes that a 3. This can't be 7, 8, or 9, so this is 6, which makes that a 9, because these add up to 15. This 9 means this can't be a 9, so this is 6, which makes that a 9. This 6 eliminates that 6, so that's 3 and a 6. This 4 eliminates that 4, so this is 5, 1, 4, 1, 5. And this can't be 9 because of this 9, so this is 6, which makes that a 9. We have a 3 and a 5 remaining here. This can't be 3 because of that 3, so it's 5 and 3. In row 4, we have 4 and 7 remaining. This can't be 7 because of that 7, so this is 4, this is 7. This is an 8 remaining. This is a 5 remaining, and we have 4 and 6 remaining. This can't be 4 because of that 4, so this is a 6, which makes that a 4. And that's a solution. Lovely logic, actually. Very, very cool use of the killer cages. That was very nice. Yeah, I just didn't... Yeah, that was really cool, actually. Very cool use of the restraints for the 15s here. And then forcing essentially all 5 of the digits to be included. And then you had 1, 3, 4 at minimum and a 1 here. That was really cool. Which forced this to be 6, 7, 8. And then we tried 2, 6, 7, which failed there. We figured out from there that the 2 could never be in this situation, no matter what, which was interesting. Yeah. Pretty cool. Yeah, that limited where the 2 could be, so we knew the 2 had to be here. With 3, 4, and 5, that was limited. We know this was 6, 7, and 8. Because the 2 could not be here. That was a lot of interesting interactions there to get to the solve. Huh. Just didn't realize it, actually. Very, very cool. Very cool puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.